In a synapse, there is the presynaptic neuron, postsynaptic neuron, transporters, receptors, vesicles, and neurotransmitters. In a synapse, a signal is sent through the presynaptic neuron to the postsynaptic neuron to communicate with your muscles and your brain. The vesicles inside then move to the membrane and release the neurotransmitters into the synaptic cleft. The neurotransmitters attach onto the receptors and pass the signal down the postsynaptic neuron. Transporters move back into the presynaptic neuron and into the vesicles to be recycled, and the process is so fast that it is already happening again. The synapse, which is affected by Zoloft, is just like a normal synapse, where the serotonin starts in the vesicles and moves to the cell membrane of the presynaptic neuron. Once they reach the membrane, they bond and release the serotonin into the synaptic cleft. Zoloft causes the reuptake transporters to take longer than normal, and it increases the concentration of serotonin in the cleft. Once the serotonin is in the synaptic cleft, they move and bind to the receptors on the postsynaptic neuron. The binding to the receptors causes a signal to be sent through the postsynaptic neuron and carry on the charge. The reuptake transporters move the serotonin back into the presynaptic terminal into a new vesicle. This causes the receptors to produce an electrical signal in the postsynaptic neuron when binding with the serotonin. Once the serotonin molecules are finally moved back to the presynaptic neuron, they go back into new vesicles just like a normal synapse. People in this medicine need it to create a higher concentration of serotonin in their synapses because they have lower levels of serotonin. Higher levels of serotonin cause happier feelings in your body.